Welcome to Got Science. I'm Bob Midden. For the next few minutes, we'll be discussing a basic lesson for wave reflection and superimposition. We'll also walk through several demonstrations that you can stage using a ripple tank. You'll find instructions for the demonstrations, a list of ripple tank sources, as well as instructions for building a ripple tank at WBGU.org. We recommend that you begin with an examination of general wave characteristics. Your students should be able to identify wave crests and troughs and the medium at rest. They should also understand the concepts of frequency and wavelength. Since wave behavior is fairly complex, we suggest confining this initial lesson to water waves. You can then revisit the topic later with additional information about sound waves or electromagnetic waves. During your discussion, lead the students to understand that waves are a form of energy that is propagating through a medium. In this case, water. This is a significant point because some may view waves as an intrinsic physical characteristic. Get them to probe deeper and comprehend the underlying cause, energy. With the motor of your ripple tank turned off, ask your students why no waves are present. Lead them to understand that energy must first be introduced to create the waves. Next, turn on the motor and generate a traveling wave pattern. Ask the students what's required to create waves. Guide them to the realization that the tank motor has introduced kinetic energy, which is now traveling through the water in the form of waves. This will also provide an opportunity to define the phrase traveling wave. Spend a few moments observing and discussing the traveling wave pattern generated on the reflector panel of your tank. At this point, introduce the concept of wave reflection. Ask your students to explain how and why a wave might reflect when it comes in contact with an obstacle. Lead the discussion to the law of reflection and illustrate several examples using a barrier in your tank. Turn on the wave machine for just a few seconds to create pulses of waves. This will minimize wave superimposition. As you proceed, you'll want to explain incident and reflected waves and the use of the normal in determining the angle of reflection. Next, steer the discussion to the concept of wave superimposition. Guide your students to understand that waves can superimpose or overlap as a result of reflection. Illustrate the concept by positioning a barrier that creates standing waves in your ripple tank. As the students observe the waves, introduce the concepts of constructive and destructive wave interference. Then lead them to understand that the incident and reflected waves can be thought of as a series of positive and negative numbers. Positive values represent the height of the wave above the medium at rest. Negative values are the height of the wave below it. Adding these numbers together at each point along the two waves creates a series of sums. And these sums are embodied in the resultant wave created through the superimposition of the incident and reflected waves. We recommend that you illustrate this mathematical aspect using some hypothetical sine waves. You'll find a spreadsheet at our website designed specifically for this purpose. Just enter values for the initial phase and phase increment to create your own series of incident and reflected waves. The spreadsheet will generate images of these and the resultant wave for comparison. We've also provided an assessment example and additional discussion topics for your reference. We hope these exercises will form a sound understanding of wave fundamentals for your students. For Got Science, I'm Bob Midden.